Hello everybody, today we'll be redoing a previous experiment. The last time I did this, I used a carabiner, which people said was coated with zinc. Now, I do not believe this is a big problem, as the amount of zinc would be just so insignificant. You'll see that in today's video. What we use again is shiny, indicating it's coated potentially with something. The end result is very good, and I'm very excited about it. We also did several other things as well, with some of our byproducts. And the very infamous sodium hydroxide shows up. I first fix a major mistake from last time, which caused us to waste some of our precious salt. I reduced the number of containers the electrolyte solution had to be transferred through. This results in a net positive of salt not being lost. However, I made a new mistake. My water was not hot enough, and so the salt could not dissolve. There are two reasons for the salt not dissolving. First reason is that we had too much salt in the water. This would result in some of the salt not being able to fully dissolve. The other possibility is that my water that was hot was not hot enough. So to solve this, I went to very drastic measures. I tested if my glassware could function in a microwave. The result was that it could survive in a microwave, but also that the microwave did not get my water hot enough. This was quite bothersome, but I continued on. Here's the part you all were anxious to see. The carabiner from last time. There is this strange white formation on it. I can only assume the worst and assume this is something very dangerous. Sodium hydroxide. So I take proper cautions while handling, but there is also the possibility that this is zinc oxide or just salt, all of which would be a white substance. This time I actually knew where the anode and cathode were, and used the patented LED test to find it. At long last, it was time to do some electrochemistry. We're going to run 5 volts through this solution. This is not a lot, however, this is what I can do safely with my current technology. This process is very beautiful. Many bubbles are produced. In fact, you can even hear the bubbles at some point. We will show that off later. What's interesting to note is that the metal begins to deform and swell. This is due to the metal corroding, and because we have the electrode at the right place, any hypochlorites that form will just oxidize the metal and be destroyed. This results in more chlorine being produced, but also a greater amount of rust forming. As I said previously, this metal is coated in something, which is usually another metal oxide, such as zinc or nickel even. This helps the metal not rust. However, I do not think this affected the end result very much, as the end result, as you will see, is a very red powder. What I found most surprising was the fact that the powder did not match the color of the liquid, and did not look red while drying, and much rather looked like a nickel oxide. Although I really doubt that it would actually be a nickel oxide. Here I am flipping the electrode. The reason I did this was so I could speed up the production of metal oxides in the liquid. As one end of the electrode oxidizes, it loses its ability to further oxidize, slowing down the process. So in order to maintain operation speed, I have rotated the electrode. I think this clip has the best sound of the bubbles. It's barely audible on the camera, however, it was very audible when I was working. If you're wearing headphones, you may be able to hear it, although you may also just hear the wind chimes. Continuing on, you can see how the electrode has deformed. It is quite impressive how such little time can deform an electrode so much. This does not occur at the graphite electrode, which is very inert. A very interesting phenomenon that has occurred here is the liquid is turned green. This is described as a green rust, according to Wikipedia. However, I have not read much about this, and I do not have time to read about this because I have to read 443 pages about polymers that are thermoplastic or very high performance. Polymers such as PBI, PTFE, polysulfones, and many others. Maybe if I get better equipment and supplies, we could make some of these. The only reason I know about this so-called green rust is because I was trying to determine what the final iron oxide product was, and so I had to look at what iron oxides existed and determine it based on color. Now, I do not know much about how this green rust works, but it just does, and it's green for some reason, and it's very confusing. One thing I tried to improve this time was filters. I tried many different filters, as I do not have coffee filters. First I tried paper bag. I tried this because when I was a kid, it would always spill my juice pouches at lunch. I also tried paper, because I thought it would just go through the paper. However, I hit a brainwave at the very end, and determined that tissues would work best. And they did in fact work, until they started to absorb my iron oxides and attempted to steal them from me. However, I was ready for this and moved the iron oxides onto a piece of metal, this metal being aluminum foil. Now, you may be concerned that this could contaminate the results. Fortunately, however, it did not seem to do so. An essential part of this process was drying. This was used to a limited degree in the first experimentation. The reason we're using drying rather than other methods of separation is that it's safest and not likely to get me in trouble, whereas methods such as distillation or even using an oven to dry would cause problems, namely me not being allowed to do this. However, in a future video, we will be doing something else that is very safe. This will be distilling water because I always keep forgetting to use distilled water, but if I have a large quantity of it on hand, then I won't forget to use it. Now just enjoy watching this beautiful filtration. A very super important thing to note about this filtration is that we have another solid in the liquid. This unidentified solid is undissolved salt, which never got electrolyzed, or maybe it did get electrolyzed and it became the very notorious, very spooky sodium hydroxide. This could also be zinc oxides. I doubt it, however. This is more than likely just salt. This is a waste byproduct that we won't even use for anything, so I must decant all the liquid without spilling this into the filter. Otherwise, this would be a contaminant and would ruin the results. As usual, the liquid goes from a very different color to almost crystal clear. It is so clear, in fact, that I don't believe this is water, but rather our original electrolyte solution plus some very spooky sodium hydroxide. I was using this ball of aluminum foil to test for any potential sodium hydroxides. The reaction between aluminum and sodium hydroxide, from what I understand, is endothermic. So even if there was sodium hydroxide, this probably would not have reacted. The end result being a green sludge, which is iron oxides. I don't know why they are green. Again, I am very confused. Iron oxides are not something I have read much about. I have not found any good papers to read about these iron oxides. I probably should go do that. Maybe I'll do that tomorrow. However, I'm very busy right now with other things, such as reading about gigantic machines used to make polyvinyl chloride, and also deciding on what to do for the next video. I also really need to sleep right now. My eyes are very tired. I sound like a machine. I am a machine. This part was really genius of me and I thought of it on the spot. This is a method of separation called crystallization, or that's what I believe it is. Basically, we freeze the solution or cool it very much. This decreases any solute's ability to be dissolved into the solution. As temperature decreases, the ability for water to dissolve things should also decrease, so thus, we should have some kind of crystals form. This was one thing I was not expecting to work, and when it did work I was very scared. Mainly because the crystals were white, and this could either be salt, zinc oxide, or potentially sodium hydroxide, although I do not know very much about zinc oxide and whether or not it can dissolve into water. So I would like to believe it is the other two, and more than likely a mixture of both. This white powder that is dissolved in the water must first be thawed out of the ice, then dried, leaving a white powder. It was fluffy, vaguely similar to what I've seen images of sodium hydroxide powder looking like. There was not very much of it, and it did not remind me much of salt, so I believe I have successfully finally produced sodium hydroxide in a very trace quantity, however. The other thing is that we have to dry this. As you can see, it's turning orange, which, I'm not sure why this iron oxide is green. You can see there's still, oh my, it's very interesting. I don't know if you can see this, but there's crystals of something inside the paper towel. Well, this is not a paper towel, this is a tissue, but it works very well for filtering things. I found that today. And the good thing is that you can see this is a very thick green material, which will, I don't want to touch that. I'm pretty sure I just touched the orange part, but... That means when it dries, it's going to basically be powder. And that's going to be good, because the powder is what we want. So, we've succeeded today. Like I said earlier, the tissue was attempting to steal the iron oxides. I could not have this. As a result, I opted to dry the iron oxides on aluminum foil. I now use a method for drying things on plastic bags instead, as it is much better to do so. However, the aluminum foil did not affect the results, but caused us a bit of a loss in yield, as it decided it would steal some of the dust that was very fine. The end result is what I can describe as Mars dust. It is orange, similar to certain variations of illuminite, but also could contain something very similar to hematite, or in other words, FeOOH or Fe2O3. Because nobody watching these videos speaks rocks, I would like to thank you all for watching and have a great Friday.